for those who think it doesn't snow in Middle Tennessee, there you go. That's last night's accumulation. I moved 900 miles to get away from this shit. So let's do a quick video today on the number one mistake I see home engine builders make, right? And I actually had this bite me in the ass not too long ago. So here's the story. I picked up a car, came with a 383, and I could see that the engine had been hand-honed, right? And it looked like they did a nice job. So I didn't check it into anything. I just slammed it together and stuck it in the car. So the short version of the long story is this thing never ran right? It had tons of power right off, right off idle. Okay, and it'd get to around 3,000, 4,000 RPM, and it just fall on its face. Couldn't make any power at all. I tried everything. I messed with jetting, I messed with cam timing. I tried every trick in the book, and no matter what I did, this thing just, 4,000 RPM, it would struggle to get to like 5,500. Off idle, you touch the throttle and it would just blow the tires off. What was going on, right? All right, well, a little bit later on, something else happened to the engine, and as I'm autopsying the thing, I noticed that they hand-honed it. But what they did was they focused all of their effort at the top of the bore. So what happened was they were trying to get rid of these ring witness marks, and I'll explain those in a second, right? And because of that, as they were honing, they kept the hone here at the top of the bore and got rid of those marks. But what they did was they created so much bore taper. Essentially, they honed the top of the cylinder like 12 thousandths of an inch over, and the bottom of the cylinder was normal size. So what happens is now, as the rings are going up and down the cylinder walls, they're expanding and contracting to compensate for the bore taper, right? So the bore's tight at the bottom, the ring closes up. Now the piston comes up and the ring's going to open to meet the bore. The problem is, at higher RPM, the ring doesn't spring back that quickly. And so once you reach a certain RPM with it, like in this case it was like 4,000, it was done. The ring couldn't come out fast enough. So it had zero compression at the top of the, and that was the other thing too. When I checked the compression on this engine, like cranking compression, it was beautiful. 160 pounds of pressure. It was like, no problem across the board. But once the RPM, got up there and the piston speed got up there, those rings couldn't keep up and it just fell off to like no compression at all. So I've seen a lot of you guys do this, where you'll go to hone your engine and you'll do everything you can to get rid of these witness marks. So what these marks are, okay, is when the piston gets close to top dead center and the ignition lights it, pressure gets behind the ring and pushes the ring out to meet the cylinder wall, okay? And that's that mark that you'll get right here. And you can see I can just barely catch my finger on it right here. So this is a normal thing. And that's why you don't see them at the bottom. You only see them at the top, because that's a witness mark from the compression event that's going on. The bore taper. What's going on, guys? When you're measuring for bore taper, don't take that into consideration, okay? Measure directly beneath it. Like so here's your witness mark right here, and if we're going to measure the taper on this ring obviously doesn't fit the cylinder. I'm just using this for demonstration purposes. You're going to check right here, okay? Not in the actual mark, but directly underneath it. And you want to make sure that section of the bore is consistent to where the bottom of the bore is. So let's say you've got a 4-inch stroke engine. You want to measure from there to 4 inches down. Anything that's below that, don't stress it. Now here's the thing. There's a lot of reasons to not bore an engine. I try to avoid overboring engines at all costs. Like every engine you'll see of my own is going to have these witness marks up here, because I have this total phobia about boring engines. And the reason for that is because the more cylinder wall you take away, the less structural rigidity the block has between the deck and the crank saddles. So the only thing keeping the heads from being pushed off and the crank from being pushed out are the actual cylinder walls on a conventional cast iron engine. So naturally, the more you bore them, the less strength there is between here and here. So that's why I try to leave them intact. And I'll dance around these witness marks up here. If you've got more than, let's say, 8 thousandths, the old rule of thumb was you want to, if you can catch a nail on it, you've got to overbore it. If you can catch a nail on it, yeah. Going 10 over won't hurt. You can reuse the original pistons. You can use a standard bore piston with a 10 over, bore, and you're fine. It's only when you go over, you go 20 or 30 thousandths, you have to go for pistons. And then you're talking about throwing $1,000 at your freshen up job. The economy goes right out the window. So the rule of thumb is this: if you can't really catch your finger on there, right, and you find that directly underneath it, the bore is consistent from here to the bottom of the stroke, leave it alone. Just hone it and pretend those marks aren't even there. The engine will run just fine. If you're measuring for bore taper, you don't need any special equipment. You don't need dial bore gauges, anything like that. All you need is a ring and a feeler gauge. You put your ring in, measure your gap, just below the witness mark, then measure your gap again at the bottom of the stroke, and if you've got 1/1000th of an inch gap here is the equivalent of 3/1000th of an inch of taper. So, and your maximum allowable taper, you'll see different engines have different specifications for what the maximum amount of taper is. So I see as much as like 7/1000th of an inch, that's a lot. 3/1000th of an inch or so is about right. So if your ring gap is consistent to with 1/1000th of an inch from directly underneath your witness mark to the bottom of the stroke, you're good to go. Put it together and go make some power. So that's it. I'm gonna go warm up. I'll see you tomorrow.